Now for these last examples, we want to see how our confidence level affects our confidence interval. This is totally wrong. It's not sample size at all. It's how does confidence level affect a confidence interval? Okay, so we have this scenario where we have 40 and 100 every time. So we're not fiddling around with the sample size, but we are changing our confidence level. Okay, so we already know what p hat's going to be. P hat is x over n. So that's going to be 40 over 100 all the way along. 40 over 100, 40 over 100, it's 0.4 every time. So that's not changing. What is going to change is our confidence level. So let's see what happens to our intervals. So I'm going to go stat, tests, and I'm going to pick letter A, which is one prop z int. I'm going to do 40 and 100. And for that first one, we want a 0.8. I'm going to go down to calculate. And there's the confidence interval, 0.33722, 0.46278. So I'm going to put that right here. And then, you know what, let's just go find all the rest of the intervals right now. So stat, tests, letter A, but we're going to change our confidence level from 0.8 to 0.9. And then go down to calculate and press enter. Okay, 0.31942 and 0.48058. So let me put that in there. And then we're going to do it one more time and change it to 0.99. So we go stat, letter A, and then leave all that alone but make it 0.99. Go down to calculate, and you get 0.27381 and 0.52619. So to find the error, what we need to do is half the width. So we have to subtract the two values and divide by 2. So let me see. Let me subtract 0.46278. So clear. 0.46278 minus 0.33722. Oh, I could have done it in parentheses, but that's all right. Then I divide by 2, and I get 0.06278, which is just what I put here. And then we'll do it again and again. So you just grab your calculator and subtract, divide by 2, you'll get that number. Subtract, divide by 2, you'll get that number. Okay, fine. So when you look at them, you can see what's happening here. As your confidence level increases, because that's what we're messing around with here, look at what happens here to your margin of error. It's getting larger. So we started off with the first one, we had an 80% confidence. Our margin of error was only 0.06%. But by the time we're done at 99%, it's at 12.6%, 0.126. So it's more than double what it once was. So that means that there's a direct relationship going on here. If you increase your confidence level, then you also increase your margin of error, which means you're also increasing your size of your interval. Because remember, size is just the margin of error times 2. So there's a direct relationship here, right? If you increase your confidence level, then your margin of error will increase, and so will your size of your interval. Right? See how these are getting larger over here? See how, look at this. This interval, these numbers right here, are farther apart than these ones that we're to start with. So we went from 0.337 to 0.463 on the first one. And this one, we're going from 0.274 to 0.526. They're much farther apart. Okay, so now let's see if that holds true for the mean. So we're going to take the same idea, but this time I'm leaving n alone, I'm leaving s alone, leaving x bar alone, but what I am changing is my confidence level. Okay, so let me go to stat, tests, number 8 this time, because you're doing a t interval. We said this was 350, 100, and the sample size is 150 through every single one of these. We start off with 0.75 as our confidence level. Okay, so you get 340.57, 359.43, and then we can just go do it again. Let's go find it. We'll find all 3 of them right now and get it over with. Number 8, everything's the same, but you're going to change your confidence level to 0.85. And there we have it, 338.19, 361.81. And let's do it again. Number 8. Now we're going to make it 85, or excuse me, from 85 to 95. So 0.95, calculate. And there we have 333.87 and 366.13. So to find the error, you just have to take half the width. So you take parentheses 359.43 minus 340.57, close your parentheses, divided by 2, or times it by a half, and you get 9.43. And then you just do that same calculation again and again and again for the other two. So you'll get 11.81 for this one and 16.13 for that one. And there we have it. So look what's happening. As your sample size increases, these interval parts are getting farther apart. So we went from 340 to 359. That's a difference of about 19. And now we're getting to a difference of, what, 33 almost. Right? So they're really increasing in size as your confidence level increases. All right, so again, just like with proportions, increasing your confidence level, right, confidence level will cause your confidence interval to also increase in size. And I just typed up what that means. So if your margin of error and your size / width, they're the same thing, of an interval, and the confidence level of that interval are directly related. In other words, if your confidence level goes up, then your size and your width of your interval also goes up. Size, width, and error, actually. Okay? They all go hand in hand. And then, oh, I guess I should say margin of error. Sorry, margin of error up at the top, the other one that I wrote like this as well, just so that way it's consistent. So size, width, and error, they all kind of go together because your size and your width are just double your error anyway, and error. Right? So for sample size, it's inversely related. So when sample size goes up, size width goes down. But with confidence level, the confidence level and the error are directly related. So when the confidence level goes up, then the size and width of the interval also goes up. All right, we're all done with that section. We've seen how to find sample size calculations, and then we've also seen how both sample size and confidence level affect a confidence interval's size and margin of error. I'll see you back here in section 9.4 to wrap everything up for